Now this is very simple. This you already know. See, if I give you a equation, just consider a equation. Let me give you a equation like this. For example, x plus y plus z equal to 10. This equation I give you. And my question to you is, how many non-negative integer solutions are there? How many non-negative, how many non-negative integer solutions are there? Integer solutions this equation has. You have an equation. How many non-negative integer solutions this equation are there? Are these two solutions same? Like you have x, y, z, and you want total to be 10. You want total to be 10. Are these two solutions same? 550, 505. Are these two solutions same? Are they same? No, they are different, right? They are different because here x is 5 and here y is here y is 5 and here y is 0. So these are different. So what template you have? You want non-negative integer solutions. You want non-negative integer solution. So what matters? Tell me what matters. What matters? What matters? It matters which, for example, if I put 2 here, if I put 4 here, then this will be 4. So you can very simply notice only this number matters. Only this number matters. Which number you are putting here? For example, 3, 5, 2. Only this number matters. And I want non-negative. It means they can be 0 also. So finally, what is this? What will be the answer? This is same as IODB. Yes or no? Non-negative integer solution. Non-negative integer solution. So this is same as these two things. These two things is same as your IODB template. This is the IODB template. So how many stars you have? 10 stars you have. How many bars you have? 2 bars you have. Answer will be 12C2. Answer will be 12C2. So this is the idea. Idea is this. Integer solution of equation. Integer solution of equation. That is same as star bar problem. But when you apply the star bar, you have to make sure. That you have non-negative integer. Remember, non-negative integer solutions, you have to make sure. Yes or no? Is this clear? Non-negative integer solutions. If I ask you this non-negative integer solutions, then this is same as star bar. Let's solve this question. What will be the answer? How many solutions such that these variables are non-negative integers? Because these are non-negative integers, you can apply the star bar. So what will you do? Very simple. You have total 11. It's like this. These are the chocolates. Okay, just consider like this. These are the chocolates. And you are a Santa. This is the Santa scenario. And the total, and these are the kids. These are the kids. X1, X2, X3. These are the kids. So you want to give 11 chocolates such that each child can get any number of chocolates. Each child can get any number of chocolates. So this is a chocolate scenario. This is your Santa scenario. Total 11 chocolate you have. These chocolates you want to give to X1, X2, X3 such that they can get any number of chocolates. Total number of chocolates should be 11. So here the answer will be what? That will be 11 stars. And there are 2 bars. 11 star 2 bars. So that is 13C2. That is same as 13C11. Very simple. Okay. Now, if I change this non-negative is very important. If I change this and make it positive integers, now what will happen? Now you cannot directly apply star bar. Can you directly apply star bar here? You cannot directly apply star bar. Why? What is the reason? Now directly cannot apply star bar. Cannot directly apply star bar. Cannot directly apply star bar. What is the reason? The reason is star bar, using star bar, it is possible that no one gets 0 is allowed. Yes, see here 0 is not allowed. 0 is not allowed. 0 is not allowed means every kid should get, remember, every kid should get how many chocolates? So these are the kids. These are the kids. And every kid should get how many chocolates? At least 1 chocolate every kid should get. So these are the 11 chocolates. These are your 11 chocolates, and this is the Santa scenario. There are 3 children. So what I will do, directly give one chocolate to everyone. Directly give one chocolate to every child. So first you give one chocolate to every child. You have x1, you have x2, you have x3. The total must be 11. What do you do? And here xi, that is greater than or equal to 1. So directly give one chocolate. So let me directly give one chocolate to him. Directly give one chocolate to him. Directly give one chocolate to him. Now the equation has changing. Now the equation is what? Now the equation is changing. Now only 11. Now only 8 chocolates we have. Now only 8 chocolates we have. Basically, directly give one chocolate to him. Directly give one chocolate to him. Directly give one chocolate to him. Now the equation is changing. Now everyone has already got one chocolate. One chocolate. So now yi is greater than, and 8 chocolate are remaining. 8 chocolate remaining. So the answer is 8 stars and 2 bars. So the answer is 10C2. This will be the answer. Okay. So remember, this star bar you can apply. This star bar you can apply for non-negative integer solutions. Non-negative integer solution you can apply the star bar directly. But if you have positive integer, then star bar directly you cannot apply. Directly we cannot apply. But what you can do, you can give chocolates and then you can apply. Remove the restriction. Tell me the answer for, okay, let's do one more. Let's do one more question. So this equation you have a plus b plus c equal to 10, such that a is greater than equal to 1, b is greater than equal to 2, c is greater than equal to 3. Now tell me what is the answer. These solution I want. This is the condition. I want solution, but these conditions. Solution with these conditions. How many solutions are there with these conditions? So very simple. Basically, it means that to this child, what it means, these are the children. Basically, directly give one chocolate to A. Directly give one chocolate to A. Directly give 2 chocolate to B. Directly give C, okay, 3 chocolate to C. Directly give. How many remaining chocolate? Now the things are changing. Now the things are changing. The remaining chocolates are only 4. Only 4 chocolates are remaining. Very simple. Now the answer will be, that will be, these are the chocolates. These are your stars. And you have total 2 bars. There will be total 2 boundaries. So the answer will be 6C2. Very simple, yes or no? Because this children, this child, this kid must have at least 1 chocolate. This kid should have at least 3 chocolate. Okay, so at least 3 chocolates should be given to this kid. So directly give 3 chocolate to this kid. Very simple. One more variation. Tell me, a plus b plus c greater than equal, a plus b plus c is equal to 10, such that a should have at least 2 chocolate, and this b can have greater than equal to -2, and there is no restriction on c. C should be greater than equal to 0. Now what it means? This is interesting. Now this, remember, I want integer solutions. I want integer solution. This variable should be greater than equal to 2. This variable should be greater than equal to -2, and this variable should be greater than equal to 0. So now this solution we can have, for example, we can have this -2, and how many for C? How much for C? Such that total is 10. How much for C? Such that total is 10. So that should be 9. Okay, are you getting my point? So why I'm saying that this variable is greater than equal to 2, this variable is greater than equal to -2, this variable is greater than equal to 0. So now what will you do? Now what is the answer? Number of solutions. How many solutions of this equation? Number of solutions of this equation. How many solutions are there for this equation? So this is actually very easy. What you are doing, basically it's like this. For this, what you are doing, if you want to handle, if you want to remove this condition, to remove this condition, what you will do? To remove this condition, what will you do? To remove this restriction, what you will do? Give 2 chocolates to A, give 2 chocos to A. Okay, directly give 2 chocos to A. To remove this condition, what will you do? To remove this condition, what will you do? What do you think? What will you do to remove this restriction? If you want to remove this restriction, then what will you do? It means you are taking 2 chocolate from B. Okay, basically it's like to remove this restriction, it's like this. To remove this restriction, think like this, that you are taking 2 chocolate from B. This B, let's assume this B already has 2 chocolate, you are taking those 2 chocolate. So basically you are taking away 2 chocos from B. Just think like this. Taking away, very cruel. So you are taking 2 chocolates from B. Okay, you are taking 2 chocolates from B. If you do this, then how many total chocolates you will have? Your Santa, this Santa. So this Santa is there. This Santa has 10 chocolates. This Santa has 10 chocolates. Now this kid is there, ABC. This kid is saying, I want at least 2. This kid is, okay, like this. So if I want to remove this, then the Santa will give 2 chocolates to, A. The Santa will give 2 chocolates to A. And if I want to remove this, means if I want to make it like this, then what it means, this Santa will take 2 chocolate from this. The Santa will take 2 chocolate it will take from this kid. So finally now the equation is A dash plus B dash plus C dash is equal to how many chocolates? 10. You are giving 2 to A, and now everything is greater than equal to 0. Now everything is greater than equal to 0. Now you can apply the star bar. So here answer will be 10 plus, okay, 2C. Is this clear? Is this variation clear to everyone? So these are the standard variations of this. Very simple. There is nothing hard here. These are very simple questions. Always think this IODB. Always think as Santa example. Santa chocolate. Very simple. Chocos. There are children and okay, so you can handle it. So now there is no restriction. Because there is no restriction, you can apply star bar. Now this is non-negative integer solution. 0 is allowed. Now you can apply the star bar. Tell me what is the answer for this. So what will be the answer for this? You have how many solutions of this equation? This equation is given to you. Okay, and this is saying that these are non-negative integers such that x1 is greater than equal to 1. X1 is, remember, these are non-negative. Like all are non-negative, but x1 is greater than equal to 1. So directly give 1 chocolate to x1. So now you have 20 chocos remaining. So basically 20 stars, and there are 4 bars. So here the answer will be 24C4. Very simple. Directly give 1 chocolate to x1. So now remaining are 20 chocolates and total 4 boundaries. So that will be 24C4. What is the answer for this? Xi is greater than equal to 2 for all I. So directly give 2 chocolate to everyone. So how many chocolates are remaining? How many chocolates are remaining? Directly give 2 chocolate to everyone. So the number of chocolates are remaining is 11 stars. 11 chocolates are remaining. And you have 4 bars. So the answer will be 15C4. Quite simple. So let's solve this question. Now the equation is x1 plus x2 plus x3 less than equal to 11. So it's like this. The question is like this. Let's assume there are 3 children, A, B, C. What this means? Can anyone tell me what this means? This actually from the Santa scenario. What this means? It means you want to give chocolates. From the Santa scenario, what this means? Tell me. From the Santa scenario, it means you want to give chocolate, but not all the chocolate. You want to give chocolate, but not all the chocolate. Like, okay, if I give 2 chocolate to him, 1 chocolate to him, where are the remaining chocolates? in the pocket of Santa, you have remaining chocolates. Yes or no? So in the pocket of Santa, you have remaining chocolate. So very simple. What will be the answer? Basically, you have total 4 variables. You can correct, you can clear, you can make 4 variables. This is pocket of Santa. So what you can do, you can create 4 variables. And now the equation will be like this. A plus B plus C plus P, that is equal to 8. That is equal to 8. Agree or not? Yes or no? The remaining chocolates will be in the pocket of Santa. The remaining chocolates. So now the answer will be 8 stars and total 3 bars. 8 stars and 3 bars. So that will be 11C3. If you have this, for example, A plus B plus C equal to 8. This is your equation. For this equation, is this solution valid? 2, 2, 2. Is this solution valid? This solution is not valid. But if I give you this equation, A plus B plus C less than equal to 8, is this solution valid? Yes, this solution is valid. So you can notice it's like this. For this, we know the answer. If A is greater than equal to 0, B is greater than equal to 0, C is greater than equal to 0, then for this question, we know the answer. That will be 8 plus 2C2. This will be the answer. It's like there is a Santa who has 8 chocolates. So you want to distribute these 8 chocolates to 3 children. All these 8 chocolates should be distributed to these 3 children. But here you can notice, here basically less than equal to 8. What this means? It means that this solution is also fine. Like this solution is also fine. This solution is also fine. This solution is also fine. Because A plus B plus C, okay, A is greater than equal to 0, B is greater than equal to 0, C is greater than equal to 0. So all these solutions are fine. But here, this solution is not fine. Here, the total, this solution is fine here, 3, 3, 2. This is fine. But 2, 2, 2 is not fine. So it's like this. You are Santa, you go to a party and there are 3 children. You have 8 chocolates. You want to give these 8 chocolates to those children, but you don't have to give all of them. For example, in this situation, you have given 6 chocolates. Now, where are the remaining 2 chocolates? In your pocket. Okay, in this scenario, you have given 3 chocolates. Where are the remaining 5 chocolates? In your pocket. In this scenario, you did not give any chocolate. Where are the remaining chocolates? Total 8 chocolates you have. Where are the remaining chocolates? In your pocket. So what you can do, you can create like this. How many chocolates you are giving to A? How many chocolates you are giving to B? How many chocolates giving to C? The remaining chocolates will be in the pocket. And the total will be equal to 8. Now the answer is very simple. That is 8 plus 3C3. You can handle the inequality. This inequality you can handle using creating a new variable you can create. Basically, this new variable will keep the remaining value, like the remaining chocolates. For example, here, as I told you, you have 8 chocolates, 3 chocolates you have given to A, B, C. The remaining 5 chocolates are in your pocket. Very simple. So this is the idea. So just create one more variable. Here we want to give 11 chocolate. This 11 chocolate we want to give, but we don't want to give all of them. Like, okay, we can give. So I can say that here, whatever chocolate I give to X1, if I give 2 chocolate, if I give 4 chocolate here, if I give 4 chocolate here, then where are the remaining chocolates? The remaining chocolate are in the pocket of Santa. In the pocket of Santa, you have the remaining chocolates. Okay. So the answer will be what? The answer will be 11 stars, and there are 3 bars. There are 3 bars. So the answer will be 14C3. 14C3. Quite simple. Okay, very simple, right? All these variations, are they clear? Like, let's solve this last variation. Every variation we have seen. Let's see this last variation. How many solutions of this equation, if all positive integers, all are positive integers, but x3 is less than equal to 3. X3 is less than equal to 3. X3 is less than equal to 3. Now, how to do this? Can anyone tell me how to do this? If this is greater than equal to 3, we can do, right? See, if this is greater than equal to 3, if I make it greater than equal to 3, if I make it, for example, greater than 3, if I make greater than 3, then I can do this, right? Yes or no? Can I do this? Now can I do this? Greater than 3. Now what I need to do? What will the answer? All are positive integers. All are positive integers. So first I will give everyone, okay, it means positive integer. So first I will give everyone 1 1. So this is the idea. To everyone you give 1 1. To everyone you give 1 1. Okay. To this x3, how many you have to give? To this x3, how many you have to give? How many you have to give? 4. You have to give 4 because x3 is greater than equal to 3. So you have to give 4. Now the equation will be like this. Now the equation is changing. Now the equation is changing. Now the equation is changing. So the answer, okay, now you have 12 chocolates. Now everything is greater than 0. Sorry, greater than or equal to 0. Now everything is greater than equal to 0. Now you can apply the star bar. You have total star and total bar are there. Okay, 4. So the answer will be 16C4. Very simple. Very simple. Okay. Now, so if you have x3 greater than equal to 3, you can handle. You can handle. But if x3 is less than equal to 3, how to handle? All are positive integer. How to handle this? Can you apply the complement approach? Either you can do by cases. So okay, there are some methods. There are some methods. Let's see method 1. So the method number 1, that is by case. You can do by case. By cases you can do. Okay, so let me do by cases. Like these are the cases I can create. X3 is equal to 1, x3 is equal to 2, x3 is equal to 3. These are the 3 cases I can create. Agree? These are the cases I can create because all are positive integer. All are positive integer. So each xi is greater than equal to 1. So these are the cases I can create. Tell me what will be the answer in this case. X3 is 1. So to everyone you give 1 1. Now x3 is out of the picture. Now x3 is out of the picture. It's like, okay, this is a child. Okay, just think visually think. This is a children. This is a child. To him, you give 1 chocolate and he will go. He is out of the picture. You give 1 chocolate, he will go. He is not there anymore. He has gone. He has taken his chocolate and he has gone. So think like this. So finally, what I can do? To everyone you give 1 chocolate. So finally, remaining chocolate, how many? Total 15 chocolates remaining. So okay, to everyone you give 1 chocolate. You give 1 chocolate. So finally, 15 remaining. 15 chocolates remaining. And now you only have 4. Now only you have this. Only 3 bars you have because now x3 is gone. Now you have x1, x2, x4, x5. X4, x5. Only these you have. So in this scenario, the answer will be. In this scenario, the answer is 18C3. 18C3 is the answer in this scenario. Okay, clear? And in this scenario, what will the answer? So you give 2 chocolate to him. So now 14 chocolates are remaining. Now 14 stars are there. And again, there are only 3 bars. There are only 3 bars. So 17C3. And here 13 stars and only 3 bars. So okay, that will be 16C3. 16C3. Because once you give 3 chocolate to x3, he has gone. Okay, so very simple. So just add all of them. Just add all of them. That will be your answer. So your answer will be what? So the final answer. Final answer is 18C3 plus 17C3 plus 16C3. This will be the answer. Okay, because once you give 3 chocolates to x3, once you give x3 3, now he has gone out of the picture. Now he is not in the picture. He is not in the picture because it's like, okay, you have given 3 chocolate and he has taken these 3 chocolate and he has gone. You do not have to give anything more. So now only x1, x2, x3, now only these are in the picture. Only these we have in the picture. Is there any other method? This is the by case method, but is there any other method? See, you know that you can handle x3 greater than 4. Complement method 2. Method 2 is complementation rule. The complement rule. apply the complement rule. Apply the complement rule means what you do, you do this total. Total means when xi is greater than equal to 1, when each xi is greater than equal to 1, then you find that minus okay, minus when x3 is greater than 4, x3 is greater than equal to 4, and remaining xi are greater than equal to 1. This is what you can do, yes or no? So what you do, first you find total. First you find total means each xi is greater than equal to 1 because each xi is a positive integer. So first you find total. In these total, you also have when x3 has 4, when x3 has 4, x3 has 5. So from these cases, you remove these cases. You remove these cases. So what is the answer? What is your total? So total will be total 15 bars. 15 bars and 4 star. 15 stars and 4 bars. So you have total 15 stars and 4 bars. So that simply means 19C4. That means 19C4. And what is this? X3. So you give 4 to him. And so there will be 12 stars and 4 bars. So here the answer will be 16C4. So the answer will be 19C4 minus 16C4. So using the complement rule, the answer will be 19C4 minus 16C4. Is this clear to everyone? Is this question clear? See, very simple. You can apply by case, you can do method 1, or you can apply the complement rule, So this is your answer. This is another variation. I'm taking all the variations. Let me tell you, every variation we have taken. So tell me now, this is another variation. How many 3-digit numbers? This is another variation of IODB. This is also IODB. How many 3-digit numbers have sum of digit equal to 9? So you want 3-digit number. Tell me, is this 3-digit number? Is this 3-digit number? Is this 3-digit number? Is this 3-digit number? No, this is not a 3-digit number. 3-digit number. How many 3-digit number? The question is asking how many 3-digit number. This is not a 3-digit number. Like this is a 1-digit number. This is 2-digit number. This is 3-digit number. So how many? For example, how many 2-digit number are there? So like that. So okay. So you cannot start with 0. You cannot start with 0 in numbers. In numbers, you cannot start with 0. In string, you can start with 0. String is a different thing. So how many 3-digit number have some? Okay, so you want 3-digit number A, B, C. 3 digits you want. So that total must be equal to 9. The total should be equal to 9. And what is this A? This A is greater than equal to 1. This B is greater than equal to 1. This B is greater than equal to 0. And C is greater than equal to 0. Correct? Yes or no? A is greater than equal to 1. B is greater than equal to 0. C is greater than equal to 0. So this is your equation. First you just make sure that whatever solution you make, that is a 3-digit number, whatever solution you will make. So this is what you want. So this is your IODB template. This is also your IODB template. Okay, so finally, what will be the answer? Like for example, what I put here, the total must be 9. The total must be 9. For example, I can put, maybe I can put 2 here, maybe I can put 4 here, maybe I can put 3 here. So this 243 is a number. This 243 is a different number. These are different numbers, right? These are different. These are different. So this is your IODB template. IODB template. Template is IODB. Okay, and answer will be, so that will be, remember A should be greater than equal to 1. So directly give A to 1. So A dash plus B plus C is equal to 8. Okay, and from here the answer will be 8 plus T is C2. Answer is 10 C2. Okay, is this clear? Is this question clear? Very simple. 3-digit number, how many you can create such that total the sum of digit is 9, so that will be 10C2. Okay, so can you notice so far? So all the following are equivalent. All the following are equivalent. These follow. Okay, like number of combination of an object, number of combination with repetition. Combination with repetition. Combination with repetition is same as IODB. IODB. Okay, and that is same as non-negative integer solutions. So all these three things are same. Agree? Non-negative integer solutions, combination with repetition, all these three things are same. Another template is multi-set problem.